Okay, today we'll look at this method on volume using integration. So there are three important things you have to know, which is the first one where we want to rotate based on the axis of rotation. It's either horizontal or vertical. The second one is the radius for the rotation, and the last one we can find the volume. So let's see the axis of rotation. If the axis of the rotation is horizontal, therefore that means we want to rotate something like this, right? We rotate horizontal, something like this. Therefore, we should use integrate dx. But if it is vertical, let's say we have something like this, we rotate about vertical axis, something like this, so we will have something like that. So this one we integrate dy. Alright, second thing, which is the radius. To find the radius, it depends on the horizontal or vertical. If it is horizontal, then the radius would be the top minus the bottom, atas tolak bawah. But if it is vertical, then the radius must be the right minus left, kanan tolak kiri. Okay, so next thing is that we can find the volume. Find the volume, we have to use the formula. If it is on horizontal, then the volume is given by pi integrate radius square. Remember, if it is horizontal, then we follow from this one, so it is based on dx. So all the values here must be on x-axis, from where to where. But if it is vertical, right, then the formula is given by v is equal to pi integrate. Same way, the radius must be square, but now it must be dy, because it is vertical, dy. This is vertical, dy. So the value on the integration must be on y-axis. Let's see one example how to find the volume using this method. Let's say we have this shaded region and we want to rotate it about x-axis, something like this, so that we'll get a volume something like this. Alright, so what we have to do first is that we have to find the radius. Alright, we know that we want to rotate about x-axis, so in our mind we know that it must be dx, integrate dx. But first, let's find the radius for the integration. Right, so the radius, if it is dx, which is rotated about the horizontal axis, so it must be the top minus bottom. So the top function is this one, so x cubed plus 1. The bottom function, okay, this is the top function, and the bottom function is actually this one. So this yellow line is given by y equal to 0, so it must be minus 0. So our radius now is x cubed plus 1. But this is the radius. Then we have to start with the finding volume. So how to find the volume? We start with v is equal to pi integrate radius square. So we take into account this radius, but we must square it. So we have to put in bracket and then we have to square. If it is dx or dy, depends on where we rotate it on. It is rotated about x-axis, which is horizontal, therefore we have to use dx. And the volume here must be on s-axis. Let's see x-axis. So from this until this. So it must be from -1 until 3. So we fill in -1 and 3. So to do this integration, we have to expand this function first. So we'll expand it. We put pi integrate -1, 3. We expand this function using the quadratic, so we get x to the power of 6 plus 2x to the power of 3 plus 1 dx. We have not integrated it yet, so we have to integrate it. So when we integrate it, be careful, do not change with the differentiation. So we have to integrate first. So x to the power of 6 becomes x to the power of 7 over 7 plus x to the power of 3, so 2x to the power of 4 over 4. 1 will become x. So filling with -1 to the 3, and we substitute with these values, and then we get the value for the volume. That's it. example where we want to rotate about y-axis, something like this. We want to rotate this thing about y-axis, something like this, so that we get a volume like a bowl like that. So in our mind that we have to use the integration based on dy, because we rotate about y-axis, or based on the axis of rotation is vertical, menegak. So firstly we have to find the radius. So the radius in this case, if it is rotated about vertical axis, so it must be the right minus left. So where is the right function? Of course this one. So what is the name of this function in terms of y? So x equal to square root y. So we insert square root y. So the left one must be this one. So what is the name of this function? It must be x equal to 0. The y-axis is x equal to 0, so minus 0. So that's our radius. So we have to simplify our radius to become square root y minus 0 is square root y. So next, only we can find the volume. So volume is given by pi, integrate. Now we rotated it about y-axis, so we have to use dy. So what is the radius? Radius is square root y from here. So we insert into this formula square root y. But remember, in this method, we have to take the radius square. Therefore, square root y square. From where to where? From where to where depends on its y-axis, because dy. So let's see the values on the y-axis. From here, which is 0 until 4. So we have to fill in with 0 until 4, because they are on the y-axis. Now only we can integrate. Oh no, we have to simplify first. So we simplify pi, integrate from 0 up to 4. Square root y square will be y dy. So we try to integrate this, very easy. So we y square over 2, 0 to 4. So we substitute with the value of 0 and 4. So it will become pi 4 square over 2 minus 0. So 4 squared is 16, 16 divided by 2 is 8. So we get 8 pi units to the power of 3. So this is the volume using this method.